Hi everyone, welcome back to our channel. Today we are going to understand about what is meant by Y parameters and how it is represented as the equivalent circuit and why they are called as short circuit admittance parameter. Let's try to understand the units of Y parameters is nothing but mhos. Why we had got it is why because y is equal to 1 by z. The units of z is nothing but 1 by ohm, which is nothing but mhos. The units of admittance is mhos, which is inverse of ohms. So this how to represent this y parameters is, so let's try to write down. Let's try to take a two-port network excited with an input port of voltage V1. The current into the input port is I1 and output also we are exciting with the voltage V2 and the current entering into the port is I2. This is a two-port network. So here we are going to write down in a matrix form to understand very clearly. So current I is equal to y into v. So this matrix, if you understand this complete, you can understand very clearly. I is equal to vy. So how many currents are there? Current I1 is there and next current I2 is there. That is equal to, so this matrix is consists of row 1, row 2, column 1 and column 2. So here you are going to have the matrix and we are going to write down what is the order of this element y11, what is the order of this element y12, what is the order of this element y21, what is the order of this element y22, multiplied with the voltage v1 and V2, which are nothing but input voltage and output voltage. So now here this Y is called as admittance matrix. Y is called as admittance matrix where V1 and V2 are called as independent variables. It's very important when you understand all these things. Where V1 and V2 are called independent variables where I1 and I2 are dependent on V1 and V2. Therefore, I1 and I2 are called as dependent variables. Now, let's try to write down. How to write down I1 and I2? So, this order of this I1 and I2 is how many rows are there? 2 rows, 1 column. What is the order of this admittance matrix? 2 rows, 2 column. What is the order of this V1, V2? We have 2 rows, 1 column. We can perform multiplication only when number of columns is equal to number of rows of the another matrix. So here matrix multiplication is possible. So therefore I am going to write down I1 is equal to row elements multiplied with the column elements. So what is the multiplication? I1 is equal to y11 v1 plus y12 v2 is the one equation. Second equation. What is the equation of I2 now? I2 is equal to, how to write down, y21 v1 plus y22 v2. These are very important equations. So no need to by heart. If you understand I1, I2 is equal to y11, y12, y21, y22 and v1, v2, then automatically we can frame out this equation. From this equation, we should say that how these are short circuit admittance parameters. Now let us try to do the first calculation. So we are going to assume output port is short circuited. Short circuited means voltage becomes zero. I mean V2 becomes zero. V2 is zero here and V2 is zero here. So when V2 is zero, then we are going to get Y11 and Y12. So therefore Y11 is equal to, how to write down Y11? Y1 is equal to I1 by V1. Next parameter is Y21. So how to write down Y21? Y21 is equal to, what is the current? I2 divided by V2. This is nothing but admittance is nothing but current divided by voltage. Okay, and the formula for admittance we'll write down is current I is equal to v into y. So I can say that z parameters are already you have been studied. So the reverse are nothing but y parameters, and z parameters and y parameters are also called dual parameters, or they satisfy the concept of duality. Here we apply Kirchhoff's voltage law. Here we apply Kirchhoff's current law. Here we express in terms of V1, V2, which are dependent variables. Here we write down the dependent variables are I1 and I2. So that's why these Z parameters and Y parameters will satisfy the concept of duality. Now, from this you have to remember. So that's how I computed y11 and y21. So similarly, what we are going to do the second step is, now output port is short circuited. And the next one is input port is short circuited. Input port means uh, input port voltage is how much? V1. So V1 will become 0. If V1 is equal to 0, then what is the value of y12? Y12 is equal to I1 by V2. Next one, if V1 is 0, the next parameter is nothing but Y22 is equal to I2 divided by V2. So successfully we have been got the 4 parameters. When you see this parameter, uh, here we are finding out the admittance parameter. I mean, we are going to find out the admittance parameters y11, y12, y21 as well as y22 by performing short circuit. What kind of short circuit we performed initially? Output port is short circuited and next input port is short circuited. So this we are short circuiting and we are finding the remaining parameter. And next step, we are short circuiting input port and we are finding the remaining y12 as well as y22. Here the ultimate units are mhos. Y11 units are mhos, y12 is mho, y21 is mho, y22 is also mho. So that is the importance of this y parameter. So now let's try to give the names for this parameter. So now let's try to represent. So y11 is equal to I1 divided by V1. Next one, y22 is equal to I2 divided by V2. So it is referring with respect to input port. That's why it is called input port, is where y11 is called as a input port or input driving point admittance. So this is driving only input. This is called input driving point admittance, where y22 is referring the output port. That's why it is called output port driving point admittance. Hope you are able to understand. Let me check out any issue is there with the mic. Okay, all right. So now that's how we define y11 and y22. Now here the element we are going to get is y12 is equal to I1 by V2. Okay. So now how to write down y12, and next y21 we are going to write down I2 by V1. So output current by input voltage we are going to call it as a forward forward transfer admittance. Forward transfer, because it is going from second port to output port to input port. So this is reverse. That's why we are going to call it as reverse transfer. And what is this parameter called? Reverse transfer admittance. This is very important names you have to recall while you are studying. So every parameter you can see current by voltage. So the first element will come to the numerator and the second element will come to the denominator. The first element will be there in numerator and second element will be there in numerator. That's how to represent these elements in an form. Okay. Now we need to write down the equivalent circuit for this network. Okay, so before drawing this, remember how to draw the equivalent circuit. So already I told, so we have I1. So what are the equations? I1 is equal to, so don't just remember this, no need to remember the equations also. I1, I2 is equal to Y11, Y12, Y21, Y22 of V1, V2. So therefore, what is the value of I1? I1 is equal to Y11, V1 plus Y12, V2 is one equation. Next equation is I2 is equal to Y21 V1 plus Y22 V2. Now let's try to draw for input port and output port. Let's try to join. Here you can see here, this is an entering current, this is a leaving current Ix, and this is another leaving current Iy. Let's try to mark. So I'm going to draw the KVL now. So the entering current is I1 with a applied voltage of what is the applied voltage? V1. The voltage at this point is V1 and 0 volts. Current I1 is entering and it is going to divide. So how it is dividing? So this is Y11 and V1, or I mean the voltage at this point is also same voltage at this point. So but here we need to have an admittance. So this admittance I'm going to draw in a box and I'm going to write down it as Y11. Okay, so I'm going to label this current as some current Ix. So successfully I drawn Ix, but at the input port I have to draw the parameters which are there at output. Therefore, I'm going to represent this with a dependent source. The dependent source is represented in terms of a rhombus, and the current Ix should leave this node, means the polarity of the current should be downward, where this current is Y12 V2. So what is the name of this current? Okay, so this current, this source is called voltage dependent. This is called voltage dependent. What kind of source? This is current source. Voltage dependent current source. Okay, so now successfully, so if you apply the KCL at this point also, you can understand very clearly. If you apply the KCL, what are the entering currents? I1 is the entering current, and Ix is the leaving current, and Iy is the leaving current. When you write down in the KVL form, entering current I am writing it as I1. How to write down the current Ix in this branch? The current Ix is equal to Vy. So what is the voltage at this point? The voltage at this point is V1 into Y. So what is the admittance? Y11. How to write down the current which is leaving? The current leaving is Y12 V2. You can see here you have been obtained an current equation which is similar to our original equation. Therefore, it is verified. Now we need to draw this. Okay, so what is the current we are having? I2. So try to draw the output voltage is V2 and the current which leaves the port is I2. So now I identify the element which is there only for output port. This is nothing but Y22. So the voltage at this point is V2 and the voltage at this point is V2. Automatically there is no element, automatically this will also be shifted to this node, and this voltage is V2, and we are going to have an admittance like this. The name of this admittance is Y22. So therefore I'm going to write down this current I2 is equal to Ix plus Iy. Ix I am going to write down it as a Y22 as well as V2 is nothing but Ix. So now we need to draw the another current. So how to draw the another current is nothing but a current which is referring the input port. How to draw that current is we have to use an dependent source. So this dependent source I'm representing with an rhombus. And what is the value of this? Y21 V1. Okay, so this is also an current source which is leaving. This current I'm going to label as some IY. This current I'm going to label as IX, and this also should leave the branch. And what kind of source this is? So voltage is there. Voltage is a parameter, therefore voltage dependent. Voltage dependent, what kind of source? Current source. This is a voltage dependent voltage source. Now let's try to re-verify and apply the equations here. Okay, so try to apply Kirchhoff's current law at the node V2, at this node. Okay, so what is the entering current? Entering current is I2, leaving current is Ix, and one more leaving current is Iy. You can see at this node the entering current is I2, the leaving current is Ix, and another leaving current is Iy. So therefore I am going to write down I2 is equal to, how to write down Ix? So it's a product of voltage into admittance. What is the voltage at this point? The voltage at this point is V2 multiplied by the admittance Y22. How to write down the current? Iy, which is also a current dependent voltage source. We are going to write down it as a Y21 as well as V1. So this how we have been got. You can verify with the previous equation whether we had written exactly or not. So you can see both are same. Now just interconnect these two equations. I'm going to interconnect input port and output port. So successfully we have been designed. So this circuit is called as equivalent circuit of a Y parameter representation. It's very important in solving number of problems. All LEC based subjects are completely dependent source. This plays a major role in understanding all this. Hope you are able to understand what is meant by an. So hope you understood. Y parameters means the units of Y parameters are mhos, and these are obtained by short circuiting input port and output port. That's why these are called short circuit admittance parameter. So Y11 is I1 by V1, Y12 is I1 by V2, Y21 is I2 by V1, Y22 is I2 by V2. So Z parameters and Y parameters will satisfy the concept of duality. Here dependent parameters are V1 and V2. Here dependent parameters are I1 and I2. So Y11 is called input driving point admittance. Y22 is called output driving point admittance. Y21 current by voltage, forward transfer admittance, reverse transfer admittance. So this is the diagram obtained by applying KVLs. But but in Z parameter we obtain the same equations of V1 and D2 with the applying KVL. That's very important. Hope you are able to understand. If you feel the content is very useful, please like the video and share with your friends and say your comments. And if you have any doubts or any confusion, let me know in the comment section. And please subscribe to this free channel, which is an useful channel for the benefit of students to understand more about the electric circuits. Yours obediently wrong. Okay, so thank you for watching patiently. So we'll meet in the next video of the problems on Y parameters. Thank you for watching.